Okay, so hello everyone. I'm Mengyi, GC engineer from SuperMap. So here I will bring you two sessions focused on practice demos with some 2D and 3D application with SuperMap at its top. After previous sessions, I believe that now you are more familiar with SuperMap products and want to learn some advanced skills that can be used in actual projects and researches. So here in the first demo, we will focus on, in the first demo, I will introduce you a series of statistical analysis methods in GIS application based on an urban land use demo. So first of all, we will have a quick discussion. So first of all, we will have a quick discussion on why statistical analysis is a necessary part in GIS application and how it is applied. Then we're going to focus on the urban land use demo using multiple statistical analysis methods to achieve goals from visualizing information to extracting hidden patterns in the data. Now let's get started. So we all know that spatial information is the very key in GIS, in which, in simpler words, that should be the location of different features. However, spatial information or location is not the only information involved in real projects and researches. As GIS applied in different fields, we usually would combine spatial information with attribute table from agriculture, natural resources management, transportation planning, and etc. And what we can extract from this combination plays a very important role in decision making because it revolves distinct characteristics of data in both spatial relationship and traditional statistics. So statistical analysis in GIS can be divided in two types: general statistical methods and spatial statistical methods. For the basic statistic information, we can usually visualize them with histogram, pie, and scattering points in GIS software and put them on the side of the map so that they can work as a supplement to the map. And as we're GISer, and as GIS professor, we would prefer spatial statistical analysis method, like directional distribution can be used to find the distribution center and direction for different features and have a quick and clear comparison. Or we can use methods like cluster and heat map to find hotspots for some specific features. And here are some examples of GIS statistics application. On the left, we can see that here we put a graphics in the map so that it can demonstrate the relationship between poverty and education. And on the right, we can see that it is the result of spatial distribution analysis for clinics, and it shows a clear unbalanced distribution of clinics, and thus we can use it as a reference to find or plan new locations for new clinics. And so now let's move to our demo. So here, as we all know, the task for statistical spatial statistical analysis in GIS is to find the stunning and concise features and patterns in simple data sets. So here in this demo, we would use only two data sets, urban land use, and another data set is roads. And from these two data sets, we will first have a brief summary on their basic statistics and features. And then we would calculate road density for each land pieces in this urban area. And finally, we will have a directional distribution analysis for different land categories. And so that we can find those categories has similar distribution patterns. And the slides and data for this demo has shared with you from Google Drive, and I believe most of you have downloaded it. If you haven't downloaded them, you can find the links in the guidebook of the workshop, and it won't take long to download the data. And now let's open SuperMap iDesktop. So here I have already opened SuperMap iDesktop 11i. That is the latest version of this desktop GIS software. And let me know if you have any problems with open this software in the chatting box, or if you are ready to do the demo, also let me know in the chatting box. We will wait for 1 minute. So if you don't have problems with the software and data set, now we will have the first task for this demo. So first, I will introduce you the interface of this desktop software. So here on the left, you can find a window that is called Space Manager, a workspace manager. That is where we are going to manage all the data or data sets connected and saved in this workspace. And then on the top, you can see here are a lot of tabs with different names. They are named based on functions. And under each tab, we have a set of tools for that kind of function. And we will use some specific tools from this tab later. So now the first thing we need to do is to connect our data into this software. So here, let me show you. So you need to unzip the data that is called statistical analysis and open this folder. Well, for the access or license for the software, you can refer back to our to the guidebook of this workshop. And if you have the trial license, now you can use all the functions and tools in the software, so you don't have to worry. And if you want to use it for business or to buy a license, then you can go to SuperMap online to get more information or contact our local sales. So here we can see that inside statistical analysis, we have a file that ends with UDBX. That is the specific data source file for SuperMap products. So we would connect it to in SuperMap iDesktop. So here, now let's going back to SuperMap iDesktop. So as we said before, we would use Workspace Manager. to manage all the data source or data sets connected into the software. So under it, we would find a node that is called data sources. Select on it and then right click, choose open file data source. And now go to statistical analysis and find the data source that is called urban land and with UDBX and click OK. Now we can see that we have opened this data source and we can expand it. Now you can see here are only two data sets inside it. So now first we would focus on the main data sets, that is the land use. So we can select this data set and right click on it. Here we can see there is an option called Add to New Map. Simply click on it. And now in the center, we can see this is a map window. We can see contains different land, a lot of land pieces for an urban area. And once we open it, we can see not only do we have a map window, but also on the bottom left, we can find a window that is called Layer Manager. And inside it, now as we have a map window, we can see the layers in this window. Now there is only one layer. And although we know each land should have a specific type of land use category, but we can't see it from the map now. So our first task is to create a semantic map to create a semantic layer for this data set. So so here I will wait for a few seconds. If you haven't opened this data set or you haven't connected the data source to the workspace. So let's have a quick retrospect. First, we need to connect urban land to this workspace. And then we simply add land use this data set into our map window. To do so, you can double click on it, or you can right click on it and choose add to new map. Either way is okay. And now here under Layer Manager, we can create a semantic layer for this data set so that we can visualize the land use category for each land piece. So select land use in Layer Manager on the bottom left and right click. Then we can choose Create Semantic Map. Now, after we click on Create Semantic Map, we have opened a new window that is called Create Semantic Map. And on the left, you can see here are a lot of types of semantic maps we can create. So here we would choose Unique Value Semantic Map. And for the style, simply use default and click OK. Once we click on it, you can see that we have added a new layer into this map window, but we can't see the differences between each land pieces because we haven't used the correct expression for the unique semantic map. So here on the right, we can see that it automatically opened a window that is called semantic mapping. Inside this window, we can set the parameters for the newly ended semantic layer. So first, under properties, we need to set the correct expression, that is the name of the field that with the records for land use category. So here, maybe we need to expand this window first and then choose the correct field expression. So here, from all these options, we can choose land use ABV. That is the field that records recorded the land use type for each land pieces. And once we click on it, now you can see that those land pieces is rendered with different colors to represent different land use categories. And here, if you are not satisfied with the current color scheme, then still in semantic mapping, you can change the color scheme. So here, I will choose the one I preferred, and you can choose either color scheme as long as you think it is proper. And that's a simple step to create semantic map and visualize the value stored in land use ABV. It's okay if you haven't downloaded the software, you can first learn the operations and practice it by yourself later. And now, as we can visualize as we have visualized the land use category for this data set, here we want to conduct some traditional statistical summary for this data set as well. So to do that, we would use a new tool. That tool is stored in the tab that is called spatial analysis. So on the top of this interface, first we need to find spatial analysis. Click on this tab. Then inside this tab, on the very left, we can see that there is a tool that is called score query. We can use this to conduct some traditional statistical summary. So click on it. And then first, the software asks us to choose the data set for query. So first, we need to expand urban land. And then choose land use. Once we have choose land use, then we can see that on the bottom left, here is a list of the fields inside land use. And then we can use this list, we can use this field list later. So first, on the right, we need to choose a query mode as we are conducting traditional statistical analysis. So here, we only want to save our result in attribute tables. So we can switch the query mode to attribute only. And then we can write our query expression. So that should be a score query expression. And as there's a lot of information we want to know, and so that the expression would be a little long, and so due to time limit, we won't type it here. So we can simply copy it from our slides. Here, I will copy it from my slides. And for my audience, here you can see from the data I shared with you, here is a PDF file. That PDF file is the same as my slides, so you can get some information from it as well. So here, I will go back to my slides. And on page 12, so here we can find under select, I have write the query expression, and we can simply copy it and paste. Then I will have an explanation on the meaning of it. So here, paste the expression from page 12 in the slides. Oh, okay. So here, I will quickly have an expression on the meaning of this. I will have an explanation on this expression. So first, all the summary we want should be grouped should be grouped by or based on the land use categories. So the first thing we want to know is land use category that is saved in the field that is called land use ABV inside the data set land use. And then the first thing we want to know is how many pieces of land are there for each land category. So here we would use count to get the total number of land pieces for each category. And then to save the result, we would save the total number of land pieces in a field that is called nland. Then what we want to know is the total number. Then the next thing we want to know is the total area for each land use category. So here we would use sum to calculate the total area and save the result in a field that is called total area. And finally, we also want to know the average area for each land category. So here we would use average to calculate and save the result in a field called average area. That is the meaning of this expression. And then here, as we said before, we want to do all the statistical summary based on land use category. So here under group by, first, we need to left click in the box associated with group by. Then we need to add the field for land use category. We don't have to type in its name and the data set and the name. We can simply use the field list on the left. So in fields, we can find the field called land use ABV. So simply double click on it. And you can see once we double click on it, it is ended into the box for group by. And then we can set how we want to save and show the result. So first, we would want to show directly show the attribute table of the results. And then also we want to save the results into our data source. So here first, check save results, and then give it a name. So I will name it as land use stand. And I will stay at this interface for a while, and so that you can see all the settings. And let me see if you have any questions. Okay, if you don't have any questions, then we can click on query to do the statistical summary. And once we click on it, here you can see it directly shows our statistical summary in a table. And here we can see that actually for this urban area, we have 7 land use categories in total. And here inside nland, we have counted the number of land pieces for each category. And also we have the total area and average area summarized for each category as well. And then, as we all know, usually we won't present this simple table, this simple attribute table to ordinary audience. They usually prefer some vivid and beautiful diagrams and graphics. So also inside SuperMap iDesktop, we can create traditional diagrams based on this attribute table. So to do so, here we can switch to Start tab. And under Start tab here, in the center, we can find that under the group, in the group that is called Browse, here we can find diagrams. And inside and under diagram, we can find here are all the traditional diagrams. We can create it to visualize our attribute data. And so here, for the first diagram, we would choose pi. So simply click on it. And now you can see that it has opened a new window, and we can put it, and we can combine it with all the other windows. Well, for the question in the chatting box, actually, all the kind of data formats you listed can be imported into SuperMap iDesktop. If you want to know if you want to learn exactly how to import them, you can go to the YouTube website, the YouTube channel for SuperMap GIS, and find the training course for 2D GIS application. So here, let's continue. Now we have opened a interface. We have opened a window for pie diagram, but now it looks weird because we haven't set the proper format for this diagram. So here on the right, here is a window called Diagrams. Inside it, we can see now we are using land use stat under urban land to draw this diagram. That's correct. But now we need to set the statistic field. So here, click on this Add button. And now, here we can see that here are only 2 fields available, but actually inside our attribute table, you can see there are more attributes we want to show. So that is because we haven't set the proper type for the field that is called unland. So here we would change the type of the field that is named unland. And to do so, first under Workspace Manager, select Land Use Stat and right click and click on Properties. And you can see that here is 4 tabs under Properties, and inside it we would switch to Attribute Table, and here you can see the list of the fields in Land Use Stat. And for the field unland, we can see its type now is wild char, and so that it's hard for us to visualize it in the pie diagram. So here we would double click on its type and then change it to int. And after we change the type of unland to int, we need to click on the apply button. We need to click on apply button on the top right. Otherwise we can't save the changes of this data set. So here, click on apply. And now we have successfully changed the data type for unland. And now let's switch back to our pie chart. So here on the right, we can see on the very bottom of Properties window, we can see here under it, we can switch between all the windows opened on the right. So here we would switch to diagrams. And now for the data settings, remember change it to land use stand. And then for the statistic field, click on add button. Now we can say unland. And now add it to the ended items. Now it looks kind of weird, but it's okay, don't worry, because we haven't done all the settings. Then for the aggregation type, that should be sum, it's okay. But for the group field, so here we need to change the group field. So for group field 1, we would change it to land use ABV. And now it looks better, and we can immediately find that the area with the area with the top with the top one number of land pieces should be residential here. And then we can also, in diagrams, we can also switch to style settings so that we can change the caption, aka the title, for this diagram, and also the font size, etc. You can do that later if you're interested. And now we can save it. Now that is under diagrams. We can simply click on save, and that would save this diagram inside our workspace. So the next time we open this workspace, we can directly see our achievement and don't have to do it again. So here, just simply save it, and you can find it under Workspace Manager. Here, expand diagrams, and you can find it. And also, if you want to use it in your own paper or projects, you can also choose to export to picture. That would export this diagram to PNG picture, and you can simply add it to your paper as well. And further, actually, we can create more sophisticated diagrams as well. But due to time limit, we won't try it during this session, but you can refer back to our slides on how to do it. And so now let's move back to the slides as well. You can find all the steps we have done inside our slides. And you can check, and you can refer back to the slides on how to set all the parameters when you are doing SQL query as well. And so here, actually, you can learn how to create a combo diagrams that combines the line and histogram together. And now, after we get the basic information from our land use data set, then we would go one step further to conduct some statistical analysis based on spatial relationship. That is to calculate road density. So here, we want to calculate the road density for each land pieces. So the first thing we need to do is to find roads in each land piece. So that is to say, for instance, like here, we have a blue road that going across 2 land pieces. We need to break it down into 2 roads, and each part of them falling in different land pieces. And then we can calculate the distance. We can calculate the length for those divided roads, and then summarize them to get, in other words, to get the sum of lengths, the sum of road lengths by land pieces, and save the sum result in the specific field. And finally, as we have get the total, we have got the total length of roads for each land pieces. Then we can define road density for each land piece as the total length of roads divided by the area of the land, and save this result into a field as well. And then we can visualize the result, aka that new field with the semantic map, like here we can see. And so now let's switch back to SuperMap iDesktop to complete these 3 steps. So here we can close it now. And here, first, we need to break down roads with those land, we need to break down roads with all these land pieces boundaries. And to do so, here we would use a new tool that is under spatial analysis. So first, switch to spatial analysis tab. And then on the left, we can see that here is a tool that is called overlay analysis. That is a perfect tool to break down roads by land boundaries. So click on it. So here, inside the overlay analysis map window, we can see that on the left, it provides diverse operations. We can choose one of them. Based on the achievement we want to get, or based on the result we want to get. So here, in this case, we would use the option that is called clip. And so here, for source data, that is the data set to be clipped, that should be road. Then for the overlay data set, that should be land use. And then for result setting, so here, first we need to set the name of the result. We would call it road divided. And then remember to uncheck keep single object. Only when we uncheck it, then we can make sure that all the road features would be break down by the land boundaries. Okay. Let me know if you have any questions. And then click OK. And now we can get a divided road. Then right click on it. Then right click on it and choose Browse Attribute Table, so that first we can have a better understanding of this data set. And then inside this data set, we can see that here is a field that is called length. But now we can see, as we have divided those features, we can find that here are features with the same length that actually shouldn't be the case, because actually these two features previously belongs to one road. And as we break them down, now there are two features, but the length value for them are not updated. So here, first we need to recalculate the length for each of the roads, and then we can summarize them by land pieces. So to recalculate the length of each road here, we can select the length first, And then you can see, as we have opened a attribute table, now on the top, there is a tab that is called attribute table. And then inside it, we can click on the tool that is called calculate geometric attribute. Simply click on it. We can use it to calculate the length for each of these road feature. And first, we need to select set the select mode. So here we would switch it to update geometric attributes first. And then for the field to be updated, that should be length. And for the geometry property to be calculated, here we can see this is a long list. And what we want to know is the length of each line feature. So here we would choose geodesic per meter. And for its unit, that should be meter. And for the coordinates, that should be the coordinates of the data set itself. And then click OK. And now you can see all the values in length field have changed. And now that represents the real length for each of the divided line features. And based on this field, we can summarize, based on this field and the spatial relationship between land pieces and roads, we can summarize the total length of roads for each land pieces. And to do so, we first need to find the tool we are going to use. That is under Data tab. And inside Data tab here, and inside Data tab, you can see that for the group that is called Data Processing, here is a lot of tools. You can expand them. And to find the tool that is called Dataset Attribute Update, click on it. And here we can see the window that is called Dataset Attribute Update. And now, here, first we need to choose data with attribute offered. That should be road divided. It's okay. And for the target data set, that should be land use. That's right, it's okay. And for the parameter settings, here is a spatial relationship. That is to say, we can summarize or add the attributes, add attributes from the first data set to the second data set based on their varied spatial relationship. So here we can use within or intersect, and we would choose within. And then for the get value, as we said before, we want to know the total length of road for each land piece. And usually there are multiple roads in one land piece. So here, for the get value method, we can't use simply a sign value. We need to use sum. So we can get the sum of road lengths as they falling in each land piece. And so here, then on the right, we need to set which fields we want to get. We want to get the sum of which field. So here, going down on the very bottom to find the length, check on it. And then we can see that here the length is from the attribute table of the source data set. And we need to set, we also need to set how we would save the sum of lengths in the results data set. So here under target field, we would choose new field here. And then that means in the target data set, we would create a new field that is called length, and to store the sum of road lengths. And then click OK. And once we complete it, now in Workspace Manager, we can find land use and right-click on it, choose Browse Attribute Table, and inside it, we can find that now here is a field that is called length. We can say for some features, this field is blank because there are no roads going across these land pieces. It's okay. And then the last thing we need to calculate is the road density. And here we have created an empty field that is called density. So here we can simply choose density, and then on the top, under attribute table, we can find the tool that is called update field. Click on it, and now we can choose we're going to update density field and apply it to the whole field. And for operation mode, we would choose to double field. That means we would calculate the value for density based on two fields. The first field should be length, and it would be divided by the value of the field area. And here you can check if everything is right through expression. And here we can find it's okay. And now click on apply. And immediately you can see the result in this attribute table. And now we can visualize this result with a semantic map. To do so here, we can switch to our map window, still select on land use, the original land use layer, and right click on it. Still choose create semantic map. And here, we won't create a unique value map. We would switch it to ranges map, and in default of style, and click OK. And then here, we would choose a correct expression for this new semantic map. Here, we would choose to be density. And now, for the classification method, here, we would change it to quantile interval. And as we can see in the attribute table here, the value of the road density is very small. So when we're creating this semantic layer, we need to change the range precision to be a smaller number, like 0.0001. And then change the range count to be 6. Now it looks better. And here you can see that here are some blank features because there are no roads going through those features. And so there's no value for road density, and we can't render them. It's okay. And you can refer back to our slides to see how we can have a better visualization result for this in such cases. So here, let me show you. So after we have done all the steps, and now here, we can only keep the original land use layer and the density semantic land use layer, and set the color for the original land use layer to be gray. So our final result would look better. And the last thing we need to know is the land use distribution. That is to say, we're going to find, that is to say, as we can see from the original semantic map, we can see the category for each land pieces, but it's not clear for us where is the distribution center for each land category, and how the spread trend for each of them. So here we would first have a directional distribution analysis, and then set a proper visualization for it. And now let's switch back to SuperMap iDesktop. So here, first we need to find the directional distribution tool that is under Spatial Analysis tab. And then on the right, we can find Spatial Statistical Analysis tool analysis. That is a group for such kind of tool. And under it, find the group for measuring geographic distributions. And under it, find directional distribution. And now, here for source data, we would use land use, and it would be grouped by the land use category, as always. And then for weight field, we would set it to be area. And then we can accept all the default settings and click OK. Now here we can, here in the map window, first we would make the second semantic map layer invisible. To do so, in their manager, click on the little eye icon before land use, and then we can make that layer invisible. And then we can add result directional into this map window, select it in Workspace Manager, and then right click. Here choose Add to Current Map. Now we have added it into the current map, but it's hard to tell what it represented. So here we would create a semantic map for it as well. In Layer Manager, select this layer as well, and choose Create Semantic Map. This time it should be unique value map as well, and use the default style. And click OK. And then under expression, we would set it to be land use ABV group, and change the color scheme to be the same as the color scheme for the land use layer. And then on the left, inside Layer Manager, we would make the original layer for result directional invisible, and then switch back to the semantic layer for it. And now here on the right, inside semantic mapping, we would choose all the items in the list. After that, we can click on Styles button on the top. And then here under Field Style, we would simply click on Transparency, and then click Next. Inside the Field Symbol Select window, we would set the opacity of all those features to be 50, and click OK. Now that looks better. And here, we can also control the visibility of each of the items inside the window of semantic mapping. For instance, here we can select on int and click on the little icon on it to make it invisible. And it's the same for ops and tens and vect. And now we only keep 3 kinds of directional ellipsoid in this map window, and we can see that these three kind of land use categories has similar distribution direction, and we can use it as a reference when we're doing some more planning for the urban area. And also, you can try it by yourself to find out more land use types that with similar directional distribution, similar distribution patterns as well. And that's all for this session. Let me know if you have any questions for this part. You can also refer back to our slides to have a quick retrospect on all the steps we have done and all the results we have got. And here I will wait for 2 minutes. Let me know if you have any questions. If you don't have any, then we would move to our second part.